Alright, so today we're going to be looking at what we can do with our knowledge of logarithms, and that's applications. And one of the first applications we can do is half-life. And here's the general growth and decay formula that we're going to use. Is this? There's several different letters that you can use, but basically this is the equation. A equals AO R to the T over N. What this means is A is the concentration you have currently, AO is the original concentration, R is the ratio of which you're doing growth and decay. Now, if it's going to be growth, the ratio is going to be greater than 1 because you're multiplying it. And if it's decay, its ratio is going to be less than 1, like half, like half-life. The half-life is the time. R is going to be half for half-life. T, now this is the tricky part. T over N. Now, T is the time that has passed in the equation, or in the question, and N is how long it takes for that ratio to occur. So suppose it was half-life. N is going to be equal to how long it actually takes to accomplish that ratio, and T is the amount of time which passes in the question itself and how much they're asking for. So that's one of the tricky parts you have to remember. But so here's one of the first half-life questions. So the half-life of plutonium is 25,000 years, and how much is going to remain after 2,000 years? Well, this type of calculation is really easy by using this formula. So what we're going to do, our original amount is, if we look at what our original amount was, we're asking how much of a given sample, and this is asking a percentage. So when you're having percentages, you always have to assume that the original percentage was 100%. You originally start with 100%, and then it's going to go down. So our AO is 100, the ratio is going to be half here, and then the half-life is 25,000 years. So in this case, N will be 25,000. So writing this down, A equals AO ratio and T over N. This is what we're trying to find. We're trying to find how much remains. So that's A. And then our original concentration was 100% because we're starting off with 100. Our ratio is a half-life, so it's half. So T is the amount of time which is actually it's asking in the question. So it's 2,000 years, so 2,000. And then that's going to be divided by the amount of time it takes to reach that half-life, which is 25,000 years. So this is our equation, 100 multiplied by half to the 2,000 over 25,000. Calculating that out on our calculator, we get 2,000 divided by 25,000, 0.5 to that, multiplied by 100. We're going to get 94.6%. So after 2,000 years, 94.6% of the substance is still there, meaning about 5.4% of it has decayed. And that makes sense because what this means is that it takes 25,000 years for a sample of plutonium to reach 50% of its original value. So if it's 2,000 years, it makes sense for it to be roughly around 95%. And that's basically a basic half-life question. And here's another question with half-lives. So radioactive iodine has a half-life of 8.1 days. And if you have 100 grams and you're going to place in a container, how long does it take to reduce to 1 gram? So again, what we're going to do, we're going to start from our formula, which is this formula right here, and we're just going to work down from that one. Alright, so A equals AO R T to the N. So, what is our final concentration going to be? It's going to be 1 gram. What are we starting off with? We're starting off at 100 grams. What's our ratio? It's a half-life question, so ratio is going to be half. What's T? T is the amount of time that they give us in the question. How long does it take? Notice they're asking how long it takes, so T is what we're trying to solve for. And now what's N? N is the number, how long it takes to reach the half-life, which is 8.1. Now how are we going to solve this? We have a variable in there, so what are we going to do? How are we going to solve this? So what this actually you have to do, you have to convert this into an equation that we can solve using our knowledge of logs. So what we're going to do, first of all, we're going to take this 100 and put it on this side. We're going to divide each side by 100 to make this one 0.01. And that's going to be equal to half, and then T over 8.1. Now this looks like a very familiar equation that we were trying to solve in the last video. This is an exponential equation. And if you remember how we solve exponential equations and how do we solve that? Well, we're going to have to log both sides, and that's how we solve a logarithmic equation. So, or exponential equation, I mean. So what you're going to do, you're going to log both sides here. So this is going to be equal to log of 0.01. That's going to be equal to log of half to the T divided by 8.1. Now, one of our fundamental properties of logs that you should remember is that we can take the power and we can put this power on the very front. And notice this will help us because this will allow us to put the T in the front, and then that's why we can solve for T eventually, right? So moving on here, what we're going to do now is log of 0.01 is going to be equal to t over 8.1 multiplied by a log of half. Now, this is the easy part. Now all you have to do is solve for t. So you're going to take the 8.1 and multiply it out, and you're dividing by log half to get your final answer, which is going to be 8.1 log of 0.01 divided by log of half is going to be equal to t. And that's the answer, and that's how long it's going to take for 100 grams to reach 1 gram. And it makes sense for that to be greater than 8.1 days, because it takes 8.1 days to reach half of its value, so it's going to take a little bit longer to reach 1 gram, about 1% of its value, basically speaking. So computing this out, so it's going to be 8.1 log of 0.01 divided by the log of 0.5, that's going to be equal to approximately 53.8 days, and that makes sense. And that's how you solve a logarithmic problem like this using your knowledge of logs. And this is why this whole logarithmic unit was invented, so that we could solve these complex problems without having to use a calculator, because we can solve for t without having to use any calculator. Alrighty, so these are kind of really neat questions, and they have various other applications and other uses like compound interest and other things, and I'll be making more videos on that as well. Alright, moving on to the next question. So you should get the hang of this by now. It's not too hard at all. So it's basically just a matter of always start with the equation and work from there. So what are we going to do? We're going to write down our equation first. Q equals, or A in this case, it's the same thing. You can use any letter you want. You can use Q's, you can use A's. I used Q's. A's are the same thing as well. So 150 grams of a substance reduces to 30 grams in 23 days. What is the half-life? So we're going to break this question down. This is Q, or the A, is the concentration, or the whatever you have right now. What do you have right now? You have 30 grams, because it's going to reduce. So you're going to end up with 30 grams. So what you're going to do, you're going to write that you have 30 grams here. Okay, what did you originally start out with? You started out with 150 grams, so you're going to write 150. It's a half-life question, so you're going to do R. Oh, no, wait. Yeah, it's going to be half-life, so R is going to be equal to half. Okay, so far. And now T is the amount of time that they specify in the question. T is 23 days. And N is the number of days it takes to reach half of it, which is the half-life. Oh, wait, that is the question. It's asking what the half-life is, so it's actually asking for what that N value is. We're trying to solve for that. So we're going to use the same procedure as we did in the last question, and that's how we're going to solve this one as well. So again, what we're going to do first, we're going to divide that 150 out and put it on this side, divide this side by 150 and divide this side by 150, because we want to get this exponential equation on its own here. So 30 over 150 can also be written as 1 over 5, so that, or also known as 1 over 5 is also can be written as 0.2. So that's going to be equal to 0.2 is going to be equal to half to the 23 over n. So now what we're going to do, how do we solve these questions? We're going to log both sides. Fair and simple. So what we're going to do, let's log them. So this is going to be log of 0.2 equals log of half to the 23 over n. Again, we're going to use our log property here, property of logarithms. If you don't know that, you should go back to the other video and watch how to use those ones. We're going to use our log property, and what we're going to do, you're going to take this value on the power exponent, we can put it on the front. Alrighty, so what we're going to do now, writing it out, it's going to be log of 0.2 is going to be equal to 23 over n log of half. And we're trying to solve for that n, so solving for n, we're going to multiply the n out onto this side, so that's going to be equal to n log of 0.2 is going to be equal to 23 log of half. And solving for n, we just have to divide each side by log of 0.2, and we will have our final answer for n, which is the half-life in this question. N is going to be equal to 23 log half divided by log of 0.2. So as you can see, it's just a matter of plugging in the values, knowing which value goes with which in this equation, and solving for it using the process of solving exponential equations with our knowledge of logarithms. And that's pretty much all it is. And when you plug this into our calculator, it's going to be 23 log of 0.5 divided by log of 0.2. That's going to approximately be equal to 9.91 days. And that's how you basically do that's how you do half-life problems, and it's not that hard at all. And yeah, so that's one application of logarithms. And another application we're going to look in the next video is compound interest, which has many uses in the business world today. Thank you for watching.